Here's a big question. Let's meet the two things we'll watch. Earth is the giant object pulling, and the apple is the small object moving toward it. First, we place Earth on the canvas as the thing doing the pulling. Now we add the apple nearby, ready to fall. Gravity reaches from Earth to the apple, even when nothing is touching it. That is a non-contact force. It means the pull can happen through space, not by a hand or a rope. So the apple moves because Earth is pulling it downward. And the apple keeps speeding up as it falls, which we call acceleration. We can ask a simple mystery question: if nothing is touching the apple, why does it start moving at all? Let's zoom in on the falling ball. Here is the ball. We'll watch what happens to it as it falls straight down. Now we add Earth below it, because gravity comes from Earth pulling on the ball. Gravity pulls the ball toward Earth. That pull is a non-contact force, so nothing has to be touching the ball. The ball's motion is downward, but the force is the reason it speeds up as it falls. Important idea: gravity is the force, and falling is the result we see. When we drop the ball, gravity keeps acting on it every moment. That steady pull makes the ball accelerate downward. Let's compare two drops. Here we watch a feather and an apple fall through air. The feather is slowed a lot by air, while the apple moves down much more quickly. A common guess is that heavier things always fall faster. That sounds sensible, but it is not the full story. Gravity pulls on both objects at the same time. The difference we notice in air is mostly because air pushes back on the feather more than on the apple. So if we want to be careful, we say the feather and apple do not fall the same way in air. The air is part of the reason, not just gravity. The bigger idea is that falling is not only about weight. It is about gravity pulling down and air slowing some objects more than others. When we ignore air, gravity makes objects speed up as they fall. That is why free fall is such a useful idea for scientists. Air changes the race. Here we compare the same feather in two places, in air and in a vacuum chamber. The big idea is that gravity is still pulling in both places, but air drag only shows up in the air test. So the feather is not losing gravity in the vacuum. It is just losing the air that pushes against it. This table compares the two drop tests with 3 columns: place, what gravity does, and what air does. Notice the pattern: gravity is the same in both rows, but air drag changes the fall. Here is the key clue to remember. When two things fall differently, we should ask whether air is helping or slowing them down before we blame gravity. Remember, gravity is the pull that makes things fall. Remember, air can change how fast something drops. Remember, in a vacuum, the feather still falls because gravity is still there. Now let's use gravity. Here we see a child on a skateboard rolling off a curb, and beside it an open parachute floating down. Notice that both are being pulled by gravity, but the parachute has a much bigger surface to slow the fall. Gravity pulls everything toward Earth, even when we do not feel it touching us. That is why the skateboarder starts to drop after the curb, and the parachute keeps drifting downward. The skateboarder is moving forward, but gravity still pulls down. So the motion can be sideways and downward at the same time. The parachute is not stopping gravity. It is just spreading out air, so the fall becomes much slower and safer. Here is the big idea: free fall means gravity is the main force pulling an object down. In real life, air can also push back and change how fast it falls. So when you jump, drop, or roll off a step, gravity is always there. The exact speed depends on the object and the air around it. Quick check time. Here's a quick check: read the options and pick the best answer. The correct answer is air pushes on the paper more than on the ball. Air resistance slows the paper much more because it has a larger surface area and less weight for its size. Gravity pulls on both objects, but the air affects the paper more. Great thinking: gravity still pulls on both objects. The big difference is the air. A flat paper sheet meets more air, so it slows down more than a compact tennis ball. If we removed the air, the two would fall much more alike. That is why free fall means gravity is the main force acting. Remember this, gravity pulls things down, even when we cannot see it. And remember this too, air can change how fast things fall. Let's wrap it up. Gravity is the pull that makes things fall toward Earth. In free fall, gravity is the main force acting on the object. Air resistance can slow things like a feather or parachute, but gravity still pulls them down.